Now what we're going to be doing is the angles associated with them. All right. If you take a notice, this is a vertical and this is a horizontal line forming a 90-degree angle. So every time I go around, I go 90 degrees. So up here will be 90 degrees. You guys can keep adding on 90 for me. Over here is going to be 180 degrees. And down here is going to be 270 degrees. So if I pick an angle between 0 and 90, that'll be in the first quadrant, and it'll look something like this. So if you give me any angle between 0 and 90, go ahead, any angle between 0 and 90. 45, it's going to be in quadrant 1. All right. Any angle between 90 and 180 will be in quadrant 2. Any angle over here in 3. And any angle from 270 to, and I forgot, where do we end up? If we go all the way around? 360, you'll be in quadrant 4. Now notice all these angles that I've drawn up here in the 4 different quadrants. Do you see where they start? They always start one part on the x-axis, all right? And that part right there is called your initial side. Every time you're going to draw an angle here, the initial side, one half of the angle will be on the x-axis. The other part could be anywhere in any of the quadrants, depending on what the degree measure is. That's called your terminal side. All right? The side that's actually in one of the quadrants is called the terminal side. Any of these angles are what's called standard position. Initial on the x-axis, terminal in one of the quadrants. All right? Let's actually draw some now. Let's draw some. Come on, not right now. There we go. Okay, so I have an angle of 145 degrees. Tell me what quadrant it's in first. And I don't need any yelling out. I'm just going to call on people. All right, 145 degrees. What quadrant should this end up as? Or in what quadrant? Okay, let's go. Who's got 13? What do we have? Yeah, quadrant 2. Why? How does she know it's quadrant 2? Because 145 is between 90 and 180. So we know it's quadrant 2. Now let's draw it. In standard position, you know the initial side's always on the x-axis. So all I'm going to have you guys do is bold in that x-axis for me so I can see the initial side. The terminal side will be in the quadrant Lorena just described to us, which is quadrant 2. Now, I am not looking for exactness, but you better be in the ballpark. 145, should it be closer to 180, closer to 90, or just smack dab in the middle? Where's 145 closer to, or is it right in the middle? Is it closer to 180? Is it closer to 90, or in the middle? Directly in the middle? Well, you can tell, can't you? What's direct? Isn't 45, if this goes by 90s, isn't 45 in the middle? What's 90 plus 45? 90 plus 45? 135, not 145, so it's not in the middle. Where's it going to be? Closer to 180. So make your terminal side closer to 180, please. Last thing you need to put on here is which way is the angle going? The rotation angle. And you guys don't know about negative angles yet, but you will in a second. We're going in the counterclockwise direction. So tell me which way you are going. $30. What quadrant? Quadrant 1. So bold that initial side. Where's that 30? Closer to 0 or 90 or halfway in between? Closer to 0. So make it closer to 0. And then your rotation arrow. All right. Let me see you do 295 on your own now. 295. Tell me what quadrant you're in. Initial side, and then where will your terminal side be? Looks good. While you guys are picking that up, what quadrant are we in here? Who's got number 3? Quadrant 4. And Megan, was this closer to the 270 or the 360 degree? 270, so let's make sure we make it close to 270. And make sure your rotation arrow is going in the proper direction. All right. Questions? Okay, well, what's the big deal with the rotation arrow? Where it could be going the other way. Okay, then counterclockwise. It could be going clockwise, and that is what we say for negative angles. If an angle is going to be negative, we go in the clockwise direction. So real quickly, go around the world with me here. 0. Now we go clockwise, and this will be not 90, but negative 90. Now we start going clockwise. Over here will be negative 180. Up top, negative 270, and then we're back to negative 360. Take the angle, negative 60. Negative 60. Watch your mouth here when I ask you this. What quadrant are you going to be in? Negative 60. What quadrant are we in? 19? Even though everybody's here? Okay. 2? What quadrant are you in? Negative 60. 4, right? It's between 0 and negative 90. Closer to negative 90 or 0, Lucas? Negative. Okay, so ready? Here we go. Get your initial side on the x-axis. That's not going to change. And he said closer to 90, and he's correct. So terminal side, 4th quadrant. But now your rotation arrow is going clockwise because that's a negative angle. Questions about that negative before I'm going to ask a challenge question now. Give me the positive angle that has the same terminal side now. Don't yell anything out. Can you guys go the other direction? Give me the positive angle that's got that same terminal side. So pretend my rotation arrow is going counterclockwise. What's this angle measurement in the positive direction? We find that angle, knowing that that was negative 60. Thoughts here? Thoughts. Here we go. 1 thought. How'd you get it? Because you're correct. 300 degrees in the positive direction. Here you go. Go all the way around. How many degrees you going? 360, but I'm stopping 60 degrees before that. Right? Go all the way around. You get 360. We know that's 60. So, yep, he's absolutely right. I'm taking negative 60 and adding 360 to it and getting, 300 degrees. So what did Alex just do? If you have a negative angle, he did what to it to find the positive angle? Added what to it? Added 360. Don't turn the page. I got a little note to write down below. Negative 60 degrees and 300 degrees. Those two we just found. The negative 60 that was given, the 300 that Alex just found. Everyone agrees they share this side, right? What's this side called again? The what side? Look above if you have to. This is the terminal side. If two angles share the same terminal side, we call them coterminal angles. I know, look at that vocab the mathematicians made. Coterminal angles. If they share the same two angles that share the same terminal side. Right? Question on that vocab piece? Fine. Okay, what if you're, okay, go ahead, 5 and 6. I got negative 270 and I got negative 110. You do not need to draw it, but I want you to find the smallest positive measure that has the same terminal side. Okay, so negative 270, and what other positive angle have the same terminal side? Negative 110, and what positive angle have the same terminal side? For 270, what do you have? 270. 2. Lucas, what do you have for 270? How'd you get it? You went all the way around, added 360, and said that would have been 90 degrees. Nice job. How about for negative 110? What positive angle shares the same side? 12? 250. How'd you get it? Added 360 to it. Nice job, Emily. Okay. Questions? Is it possible to have an angle bigger than 360? You're darn right. We can do it. 640. Let's graph it first. 640. Let's graph it. Well, you know I end at 360 here, right? What if I went back around here? How could I find out what angle? I know it's 90, but what else? If I go 360, add 90 to it, what do I end up with? 4. 4. Okay, I got no problem. 15, what angle do I end up with? It's got 15. Okay, I'm going 0, 90, 180, 270, but I got to hit 640. So I'm going to keep going around now. So I'm at 360. What can I do to this 360 to find the next angle? They're going by what here? 90s, right? So take 360 and add another 90. We got 0, 90, 180, 270, right? And we're back at the beginning at 360. I got to find out what quadrant 640 is at. So 360 plus another 90. So this is 450 degrees up here, still not at 640. So add another 90. Where am I now? I thought that was, this is 5. This was what, 450? 540, still not there. Down here, 270 and 630, still not at 640. So this will be 360 and. Okay, so where did 640 end up? In which quadrant? Quadrant 4. Everyone's with us there. Ended up in quadrant 4. And it ended up closer to 630 than 720. So make your terminal side closer to 630. If I did this, is that correct? 640. That's not 640. That's a lot smaller than 640. So what do I need to keep doing with my rotation arrow? I got to do a little pinwheel action. Ready? So here you go. Ready? 360. Keep going. 640. So I got to go all the way around to show who's ever reading this that I went more than 360. Can you give me another angle that shares that same side other than 640? That's a little smaller than 640. What is it? Why? So all you're doing is taking that 640 and subtracting. Taking that 640 and subtracting 360. Yep, and you end up getting 280 degrees. Yep. Those two angles share. Cooper, what did you just do? Any angle that measures greater than 360, how can I find an angle between 0 and 360? Subtract 360, yep. So there are two angles down there, 550 and 750. You do not need to draw it, but I do need to state the quadrant. All right, state the quadrant and tell me the smallest positive angle coterminal. Go ahead. The smallest possible angle, smallest positive quadrant, and then the angle that's coterminal to it. 550, 550. What quadrant first? 18. What quadrant are we in? Third quadrant. Got it. And what about an angle that shares the same terminal side as it? 190 degrees. Nice job. Good so far. 750 now. 750. What quadrant first? 3. What quadrant? Quadrant 1. And let's see if we fell into the trap or not. How many of you had 390? It's got to be the smallest one, right? Because what can you, you're right with 390. It's coterminal, but it's asking for the smallest one. What can you still do to 390? So is there a smaller positive one? Yep, it's 30 degrees, so watch out for that. Okay, we are looking for the smallest positive one you can have. 390 is correct, but unfortunately it's not the smallest positive. Questions? We got one part here. And what if it's both? Negative and more than 360. What do we think? What do you think you would do to negative 400 to get the smallest possible measure we could? To negative 400, what could we do to it to start making it go to the positive direction? Here we go. Megan again. What do you think I can do? Add 360 to it. Yep. Add 360. But what's the problem here, guys? What do you get? Negative 40 degrees? Does that follow the directions? No, it said smallest positive. That's negative. So again, add. Keep adding 360 until I end up with it. So it ends up being what up here? 20? Who's got 20? Nobody. 2? What is it? 300N? Yep. And then go ahead negative 900 real quick. You're going to have to add 360 a couple times. $900 simplified down to, here we go, 5. What did it simplify down to? What was it? $1.80. Yep. Anything for me? Stop here right now because it's a little bit different going on for the rest of the notes here that we have to do. Anything right now? Drawing negative angles or making it smaller? Yes, Cooper. No, and I'm going to talk about the 90, 180 and where they're actually located and what they're called at the very end of today. All right, but good question. No, they are not considered in a quadrant. Okay, questions? All right, let's go to the second part of today, which is called a reference angle. Here we go. This diagram's a little crazy to look at right now. All right, so look at what I did is I graphed an angle in the second quadrant. Okay, I don't know, whatever degree measure it is. It's in the second quadrant. Every single angle you graph has a reference angle. Take a look at the definition. It's the positive, whoa, there's a little geometry term, acute, anybody? Between 0 and 90. Okay, so every angle has an angle that's called a reference angle that's between 0 and 90, and this is how it's formed. It's formed between the terminal side and the X, not the Y, terminal side and the X-axis. So this angle right here, I'll abbreviate it REF for reference angle. That angle right there would be my reference angle. All right, every angle has a reference angle that's between 0 and 90. We're going to try to find them right now. Okay, so every angle has a reference angle. How's it formed? Between the terminal and the X. Hey, notice I didn't point to this angle here. That's between the Y-axis. It's between the X and the terminal side. All right. You are going to see more and more Greek letters in this unit. Usually we take a Greek letter, in this case beta. Anybody ever seen that one before? Except on the frat houses. Beta, it's unknown angle. That's what it means. All right, an unknown angle. That's what we're going to use the Greek letters for. You're going to see this a ton starting tomorrow. Anybody ever seen that one before? Theta. Okay, theta. All it means is an unknown. Instead of calling it X or Y, we use Greek letters for unknown angles. Okay. So I have an angle of 160. All I want you to do, draw it for me. Draw it with the correct rotation arrow. 160 degrees, draw it in the proper next to the closest axis. 160, that's all I need you to do is just draw that bad boy for me. What quadrant are you putting the terminal side in? 18? Quadrant 2, closer to the 180 or the 90? The 180, thank you, Matt. So closer to the 180. Okay, make sure we put the rotation arrow there, telling me it's going in the positive direction. Okay, now ready for the reference angle. The reference angle, let me highlight it on mine. Everyone look at your terminal side, the x-axis. Do you see that angle that's being formed between the terminal side and the x-axis? That angle is the reference angle, and it's less than 90. So your answer right now should be less than 90. How the heck do I find it then? No, remember what you know. This angle's what? That angle's 160. If I go all the way around to here, that's going to be how many degrees? Okay, use that knowledge now. Use that knowledge that you know this is a 160 degree angle. This is 180 to find that reference angle. What are we looking at here? Who's got one? Alex, what are we looking at? Okay, how'd you get it? Everyone see what he's doing. He's taking that 180 minus that 160 degree angle. Here's how we're going to write it. We're going to write beta, which was our original angle, and we're going to put a subscript r down below that says, hey, that's the reference angle for it. And yep, he did 180 minus that 160, which got him a reference angle of 20. Again, between 0 and 90. So we're good. Okay, go ahead. Graph 300 degrees now. Graph 300 now. See how we'll approach this one now it's in a different quadrant. Okay, your reference angle, because here's where kids start tripping. X-axis and the terminal side. A lot of people are going to say that's the reference angle, but what axis is this? That's the Y. No. It's the x-axis and the terminal side. Everyone see that acute angle that's from there? That's the reference angle. How can I find it? All right, you know that this angle's 300, right? And you know if I go all the way around, I'm going to end up where? 360. What can I do with those facts right now to find that reference angle? And remember, it's got to be between 0 and 90. I'm going to find that reference angle. 20? No. 18. How? Are we okay on why Matt is using 360 versus Alex who used 180 last problem? Okay, I'm only going from here to here. I only needed to go from here to here for 180, and now I got to go all the way around for 360. So yes, you are correct. That's a 60-degree reference angle. Questions? Go ahead, 210. Let's go, 210. I think we're picking this up, 210. So graph 210. Try to locate your even though if you don't know how many degrees it is, try to find where the reference angle is we're going to find. We're going to find the degree measure of. Even if you don't know how to find it, that's fine. Oh, that's 210, not 110. Do we see where the reference angle is? Ready? Terminal side and x-axis, not the y. We're not finding this one down here. Be careful. Okay, terminal side, x-axis. All right, well, we know that angle's 210, and we knew from here to here was 180. Don't use the 270. If you try to use 270, you're finding this angle here. All right, and that's not our reference angle. So what am I going to have to do here to find that reference angle? 10? No 10? How? I take the bigger angle, 210, and subtract what from it? That 180 degrees from here to here. Yep, 210 minus from here will give me that angle of 30 degrees, which is between 0 and 90. You are correct. Questions? So, okay, this is probably what's going through your brain right now. Should you ever use 90 or 270 in your calculations? No, because what axis are 90 and 270 on? The y. You should never be using 90 and 270 to calculate the reference angle. All right, because it will always be on the x-axis, 0, 360, 180. And then we get really confused when I throw this one at you, 78. Because what quadrant's 78 in? It's in the first quadrant, right? So if I graph this with you real quick, 78 going to be closer to 90. So it's going to be somewhere up here. And you're like, what? Well, first of all, where is the reference angle? No, I don't care what it is. Where is it? It's a lot of your, it's right here. There it is, right there. No. Go back to the definition. What did we say? That a reference angle has to be between? That's bigger than a right angle. That's bigger than 90. That can't be our reference angle. So where else could it be? If an angle's in the first quadrant, it's its own reference angle. 78. Right? Because if you did 180 minus 78, you're going to get an angle bigger than 90. Can't have it for a reference angle. I don't care. All right, 78 degrees. So if an angle's in the first quadrant, it's already its reference angle. How do we feel about this? Because the only thing we have to do now to finish this up is make this negative now and find the reference angle. Still between 0 and 90, though. Okay, well, I'll let you guys. Negative 110. All right, negative 110. Should probably draw it, right? To get a little glimpse of what this bad boy looks like. What quadrant are we looking at for negative 110? Third? Closer to negative 90, right? Okay, gotcha. And we're going clockwise because it's negative. Okay, do you see, forget about what it is in degrees. Do you see the reference angle? not the y-axis, with the x-axis. Many different ways here. I am not going to teach one distinct way. This is how you do it. Find how many degrees that's going to be. Thoughts on what that angle is there? 7? 70. Yep, 70. A couple different ways here. You could say, okay, that's 180, right? Well, I already have 110, so there's 70 left to go. Or what you could do, some kids in third period were making this into a positive angle first by adding 360, and then figuring out what that angle was and subtracting it from 180. It's up to you. Okay, it's up to you. I am going to let you go on your own for these next 3 here in the next 3 minutes. 6:05. What's up? You tell me. What's the first part of our directions we went over today about a reference angle? It has to be correct. It's got to be acute. Good question. All right. When you guys get to these bigger angles, what I would suggest is making them a little smaller. Okay, make it a little smaller before you deal with them. Okay, so I'll come around, help you guys out.